As you know, all the planets in our solar system orbit the sun and bring a sense of order to the place. But guess what? There are two planets that could collide with each other and cause a cosmic catastrophe. Here's Neptune, the most faraway planet in our solar system. It's 17 times heavier and 4 times bigger than the Earth. It's 30 astronomical units from the Sun. 1 AU is the distance between the Sun and the Earth, so it's 30 times farther away from our star than we are. And Neptune makes a complete circle around the Sun in 164 years in an almost perfectly round orbit. Neptune is cold, calm, and stable. But there's one planet that can ruin this balance, Pluto. It's a dwarf planet covered in rocks and ice. It's 6 times lighter and 3 times smaller than the Moon. We're interested in its orbit. If you look at a map of the solar system from above, you can see that it's not round but elliptical, so it's a slightly flattened circle. At its furthest point, Pluto is 49 Earth-Sun distances away from the Sun. When it moves, it comes closer to the star. At its closest point, Pluto is about 29.5 AU from the Sun. That's closer than Neptune. So, hypothetically, they could collide. Let's look at this collision from the front row. A little closer, please. Good. Neptune and Pluto are slowly approaching each other. They're both very cold worlds, but they begin to interact with each other gravitationally. Just like two magnets, it warms them up from the inside. Neptune is a gas giant. There's no solid surface there, so there's not much change in it yet. But Pluto has a rocky surface. Because of Neptune's gravitational influence, it's starting to crack. Pluto experiences continuous earthquakes. This causes it to heat up even more. When Pluto almost touches the gas giant, it begins to crumble from the inside out. Plus, Neptune has a very dense atmosphere, so the dwarf planet begins to ignite from friction with the gases in the upper atmosphere. Pluto is now very hot on one side and very cold on the other. This causes severe deformation, and it begins to crumble. Half of the dwarf planet's fragments remain in Neptune's orbit. They will collide with each other until they turn into dust and become new rings of the big planet. Other fragments will burn up in Neptune's atmosphere, and the biggest rocks that remain of Pluto will fall through Neptune until they're completely burned into dust. Neptune literally ate Pluto and continued its orbit without any change, all because the gas giant is 20 times larger and much heavier than the dwarf planet. So this collision would do no harm to Pluto. But it couldn't have happened in the first place, because their orbits don't actually cross. Let's look at the map of the solar system again, not from above, but from the side. All 9 planets here are on a horizontal line from the Sun. The distance between them is great, and their orbits don't cross. Here's Pluto's orbit. You can see that it's tilted relative to the horizontal line of all the other planets. It starts at the top, then dives under the orbits of the planets and comes back. So Pluto can never collide with Neptune. Still, planetary collisions have occurred in our solar system before, and thanks to these collisions, life appeared on Earth. Let's go back in time to almost 4.5 billion years ago. This ball of hot lava is Earth. It just formed from a cloud of dust and began to cool. But then, a wandering planet the size of Mars appeared on the horizon. It's called Theia. It was inevitably approaching our planet. The collision with Theia happened at a perfect angle. If Theia had hit us head-on, both planets would have been smashed to pieces. But it hit us almost at a tangent. Theia knocked some of the matter out of the young Earth and crumbled into rubble itself. It could no longer continue its journey because the Earth caught it in a gravitational trap. A large fragment of this planet remained in our orbit. Smaller fragments crashed into each other, falling to Earth or joining the remains of Theia. The dust settled, and we can see the familiar picture, the Earth and the Moon. This is the main theory of how it came to be next to us. Scientists say that it was this collision that caused life to appear on Earth. Theia brought a lot of ice on it, which turned into water on our planet. The new moon stabilized Earth's rotation, and conditions on the planet became perfect for the emergence of life. Another collision could create a blast wave that would spread out thousands of light years. Stellar collision. This usually occurs in binary systems with a white dwarf and a regular star like our Sun. A white dwarf is the remains of a star that has gone out. As the stars get together, they start to move around each other in a spiral-like dance. The white dwarf pulls down the upper layers of the larger star. This hot plasma and stardust form a luminous disk. The two stars get closer and closer. When they finally merge, this causes a chain reaction in the core of the hot star. The massive matter presses on the star's core too hard. This causes the innards of the combined star to heat up even more, and it expands, creating a supernova. This is one of the brightest events in the universe. The light from the explosion can be seen hundreds of light years away. Another spectacular view is the collision of a star with a black hole. Black holes are the heaviest objects in the universe, and their gravity is incredibly strong. So when a star and a black hole get close, the black hole starts eating the lighter matter of the star. The hot plasma, like spaghetti, heads toward the heart of the black nothingness. For an observer, this plasma seems to settle on the very edge of the black hole. It's called the event horizon. The thing is that time is much slower near such a heavy object, so we think the matter stays on the event horizon, but in fact, it's long gone into the heart of the black hole. As they get even closer, the black hole starts to literally tear the star apart and swallows it whole. At this point, the black hole spits out about half of the star's mass in the form of a beam of energy right out of its black heart. The other half of the star's mass becomes the black beast's food. We know of many black holes in our universe. The heaviest of them usually lies in the centers of galaxies. They can be millions of times heavier than the Sun. But what would happen if two black holes collided with each other? Our scientists had the opportunity to observe such an event. Two black holes weighing 66 and 85 solar masses gradually approached each other. They danced together, bending the light passing by them. But then they merged into one enormous black hole, weighing 142 solar masses. That same second, the new black hole released gravitational waves into space with an energy of 9 solar masses. Scientists were able to catch these waves and observe the merging of the two black holes from the front seat. But this event actually happened about 17 billion years ago. We're only now seeing it because the particles of light and gravitational waves took so long to travel the distance of 17 billion light years to Earth. Now consider a galactic scale collision. Literally, it's a collision of the Milky Way and the Andromeda galaxy. This event will happen in 4.5 billion years, so stay tuned. The Milky Way has almost 100 billion stars. Andromeda has about 1 trillion. As the galaxies approach one another, they'll make several circles around each other. At that time, some stars may be ejected from the galaxies like from a slingshot. Then Milky Way and Andromeda will begin to merge. One scenario here is that our solar system will collide with another star system from Andromeda. In this case, there could be a stellar collision and a supernova afterwards. Our world would be destroyed. Another option is that the Sun would be ejected into dark space. In this case, we may not even notice the difference. All we'll see on Earth is a gradually disappearing starry sky, as our solar system will travel through dark space away from the home galaxy. But the most likely scenario is when the galaxies merge, it'll be completely painless for us. In fact, the space is very wide, and there's room for all the stars from both galaxies. The only difference is that we'll see a lot of new stars in the night sky, along with flying saucers from Andromeda. Nah, not really. But it's not the collision of galaxies that we should be worried about. It's our Sun. In 4.5 billion years, it'll become a red giant. It'll expand, swallowing up the nearest planets. Earth will probably be the first planet near the Sun. It'll be so hot that all life will simply disappear, and no one will be able to watch the galactic collision.